So you've probably seen this screen before. This screen is the prompt for a program that's called needrestart. Now, needrestart is a program in Linux that tells you if a service needs to be restarted. The way this works is the process scans all of the user mode processes as root and then determines if those processes are using an outdated library. It says, hey, you just updated the libraries, you should probably try and restart these processes. Now, what's interesting about this is that the needrestart process that lives on basically every Linux-based server in existence has recently been found to be vulnerable to a privilege escalation. And this bug has actually been hiding in Linux for about 10 years. In this video, I want to break down exactly what we're talking about. I want to go through the Qualys report, the team that actually found the bug, and talk about their breakdown of the bug. Then I'll show you how a hacker can exploit this and how you can mitigate the bug yourself. Now, real quick, if you're new here, hi, my name is Ed. This is Low Level TV, a place where I talk about software security, cybersecurity, and a bunch of other crazy random crap. So if you like that or just want to hang out, hit that sub button. Also, as you can see right here, follow me on all socials. I'll actually be streaming on Twitch later today. We'll see you there. Okay, let's keep going. So as I mentioned before, I did not find these bugs. These bugs were found by this organization called Qualys Security. Now, they did drop 5 CVEs in needrestart that are LPEs, local privilege escalations, that allow you to, as a user already on a computer in an unprivileged context, become a privileged context, be the root user, which allows you to have basically like God mode over the server, right? They dropped 5 of these. I'm not gonna go over all of them today, but I wanna go over the biggest one that I think is the most kind of important to me, or kind of highlights the nature of how easy this bug is to exploit. The way that needrestart works is every time you do any kind of process that updates your system, an apt update or an apt upgrade, needrestart is going to run through and it's going to check all of the processes that are running and see, does that process depend on a library that you've updated? Did you update libc? Did you update Python 3 libdev, something like that? And that's going to ask you, do you want to restart that service? And that's actually exactly what this is doing here. I updated a library, so it says, okay, user 1000 service depends on an old library. Do you want to restart it? They go into exactly why they looked into this process, which is actually really interesting to me as a security researcher. So much of this is art in deciding what target to look at, what thing to investigate. And they saw when they were doing an apt-get upgrade, which is what we just saw here, there's a little prompt that says scanning processes. And I can actually show you that real quick. When you're doing a needrestart, you'll see here, it'll say scanning processes, right? So they're like, wait a minute, hold on. What is printing this message? Is it scanning userland processes as root, even the processes that do not belong to root, right? So like the initial question is like, is there a vulnerability in the way that the root running process, needrestart, which has to run as root to get all the privileges to all these processes, is there a vulnerability in the way that it does this? And they immediately found one that's really interesting in the topic of today's video, 48990. Now, to determine if different kinds of processes need to be restarted, there have to be different ways of scanning that process. And so in particular, there is a custom needrestart interpreter or a needrestart checker for a Python process. And the way this works is it has to go through and figure out where the Python path environment variable is. A Python path environment variable is the environment variable that could overload where Python is loading its libraries from. Because by default, it's in like user local share Python lib or something like that. But you can choose to put Python path, the place where you get your Python libraries from anywhere. And so what it does is it searches through every process. If that process is Python, it'll look in procpid environ and pull out the Python path environment variable and then use that to later run Python. Okay, let me tell you one more time. And I want to, if you're a hacker, if you think you know how computers work, it will take out a user-controlled Python path variable, which is telling the computer where to load libraries from, and then using that user-controlled Python path to then run Python. Okay, so the way that people exploit this is you put a malicious shared object that will just pop a shell into a local user-controlled Python path, and you just sit there and you let Python run. And what inevitably happens is that when needrestart runs, it will say, oh, there's a Python running. So I'm going to take that Python, I'm going to extract its Python path, and then I'm going to run this function here. And in doing that, it will run whatever code you specified as the user in that shared object as root. And I actually have a proof of concept that I found on GitHub right here. Let's go right into it. All right, so we're gonna go into hardcore hacking mode here and actually run the proof of concept that takes advantage of this vulnerability. I do have a vulnerable version of needsrestart installed. If you actually sudo apt upgrade right now, it will upgrade you to the newest version of needsrestart that is not vulnerable to this bug. But I have the vulnerable one installed, so we're gonna mess around with it and see what it does. So the way this POC works is you run start.sh, and it does a few things. First of all, it makes a new version of importlib, which is a library that is always imported by default in Python. And the source code of importlib that it emits as init.so, which is a shared object that Python will always load, is in this lib.c file. And the lib.c file is very simple. All it does is it creates a library with a constructor. And a constructor in a library is a function that will always run regardless of if you import it or not, right? This will run when the library is loaded, hence constructor. It will make this command here, it will copy binsh to temp POC, and then it will command that, it will change the permissions of that to be a setuid root binary. So now we have temp POC as setuid root, and we can use that later to run that program. So we're gonna run this program, and it will create a copy effectively of binsh with setuid root in temp. Okay, and then we're not gonna run this yet. All we're doing is compiling it so that it lives locally in this importlib init.so file, right? And then we're going to set our Python path to be the current path, pwd, and then run python3 e.py, okay? So what is e.py? e.py, literally all it's doing, well, first of all, it's checking to see if we've already ran this, and if not, it's gonna remove it. That actually doesn't work because it's a setuid root binary. It's owned by root, so this actually fails. But what's happening here is we are literally just waiting until temp POC exists, and then we're going to run temp POC. And we're gonna do that in an infinite loop and just wait for it to be alive, right? What we're doing is we are compiling a malicious shared object, putting it into our Python path, and then we're waiting for needrestart to run. When needrestart gets run, it's gonna scan all the processes that are alive in the CPU, and if one of them happens to be a Python process, it'll execute the vulnerable code, right? It'll take the Python path out, it'll run a copy of Python with our malicious Python path and run our code as root, copying the temp POC out, and then giving us a root shell. So if we literally do something that would trigger needrestart right now, we'll get a shell. Now, the reason I'm not gonna do sudo apt upgrade or sudo apt update, which is something that would actually trigger the bug, is because by doing that, I would actually replace my current vulnerable needrestart version with a not vulnerable version, hence defeating the purpose of the video. But for the sake of explaining how this works, if an admin were to come onto the computer and do sudo apt upgrade, or if there was like a cron job that would run nightly to do sudo apt upgrade, prior to this bug getting patched, it would trigger the bug. Sudo needrestart, which again is the act of an administrator somewhere else on the CPU doing something that triggers the vulnerable needrestart, right? So by scanning the processes, it found our Python process. The Python process had a malicious Python path that it then used to run our shared object, or init.so, that copied a version of binsh to the temp directory with a setuid root binary, and that gave us a shell. Very interesting. Okay, so you'll probably see real quick that we are actually not root yet. I mean, we have a root prompt, but the ID is not set effectively. So we have an effective user ID of root, but not an actual user ID. So the way we change this, we just do sudo su. And because our effective user ID is already root, it'll elevate us to an ID, where now our UID, our GID, and our groups are all root. So we are now root on this system. Pretty interesting. Now the question I know you're all waiting for me to answer. I know the question you have on your mind is, would Rust have fixed this? No, not at all. This vulnerability is very obviously a logic bug or a misuse of the Linux environment system, and nothing about Rust would have fixed this. Like, you could have done this exact same, even if you wrote this part of needrestart in Rust, you're literally just taking environment variable, putting it into another process and running it. Like this would have been triggered in Rust as well. Anyway, guys, that's it for now. I think you really should go read the report by Qualys, really good stuff. Go mess around, go try to do this yourself. Go pop your own root shell on your system. And that's it for now. Also, guys, I'm trying to stream more on Twitch. If you want to hang out on Twitch, go hang out with me at twitch.tv/lowleveltv. And we'll see you in the next one. Thanks, guys. Bye.